Hey everyone, this is Morgan coming back at you with a little bit more of the stoichiometry lecture. We're on page number 3 of the outline today, and we're going to add some roads to our roadmap. This is that classic roadmap that we introduced last year. Okay, it is incredibly helpful for us. Okay, when we want to go from moles of A to molecules of A, we multiply by Avogadro's number, 6.022 times 10 to the 23rd. We divide by Avogadro's number to go from molecules to moles. When we want to go from mass to moles, we divide by the molecular weight, sometimes called the molar mass. And when we want to go from moles to mass, we multiply by the molecular weight. When we are going between mass and liquid volume, we use the concept of density. And we use the balanced chemical equation, or what some people call the mole ratio, to go between the moles of A and the moles of B. Okay? So, now, a couple of really straightforward problems. Let's balance this nice equation right here. I've always loved this as a sample equation. Sodium kicking hydrogen out of water to form hydrogen gas and sodium hydroxide. So if 10 grams of sodium reacts with excess water, how many grams of NaOH can be produced? So let's start with our 10.00 grams of Na times. We have our 1 mole of sodium is 22.99 grams of sodium. So think of it, if you like, as from mass to moles, we divide by the molecular weight. Or think of it, you have grams, you get grams to cancel by putting molar mass on the bottom. Either way, okay? Then moles A to moles of B. Look up here, 2 moles of sodium is going to make 2 moles of NaOH, because I'm looking for NaOH. Now I'm looking for grams, so I got to go from moles of B to mass of B. 1 mole. NaOH has a molar mass of 40.00 grams of NaOH. Now, grams of Na cancels, moles of Na cancels, moles of NaOH cancels. I run this through my calculator and I get 17.40 grams of NaOH. Okay? Sorry. So, there you go. You did lots of these last year. You got pretty good at them. Okay? This is a skill that we're going to use over and over and over again. Okay? Now, another one that involves a solution. Balance our equation right there. What mass of PbCl2 can be formed from the reaction of 50 milliliters of 0.250 molar of NaCl with some excess lead-2 nitrate? 50 milliliters is 0.0500 liters. Remember, molarity is actually in liters times 0.250 moles over liters. I seldom just actually use the capital M. I write it as mole per liter. NaCl times. Now what that did was that got me onto the roadmap up here at moles of A. At moles of A. Now 2 moles of NaCl and 1 mole PbCl2, 1 mole PbCl2 and the molar mass is 278.10 grams PbCl2. Liters cancels liters. Moles of NaCl, moles of NaCl, moles of PbCl2, moles of PbCl2, and my calculator got me 1.74 grams of PbCl2. Okay? Now, that is a skill from last year. You should be completely competent at it at this point already. If not, you need to go back and practice it a lot because we're going to dive into this one head first. Okay? Hopefully you also remember the idea of percent yields. The actual yield divided by the theoretical yield times 100% equals the percent yield. What is the need for something like this? Well, it's the chocolate chip cookie recipe. And I look at that bag of chocolate chips and it says something like, makes 3.5 dozen 2-inch cookies, and never do I get 3.5 dozen 2-inch cookies. What's the problem? Well, one of the problems is I make the cookies a lot bigger than 2 inches. That might affect it. Or I do so much quality control while making the batter, testing it, tasting it, making sure that it's okay, that, I only end up with 2 dozen cookies. So my 2 dozen cookies is the actual yield, and the 3.5 dozen would be the theoretical yield. Okay? So I think you get the idea there. All right, that's page 3 of your lecture outline.